Saraswati
Welcome, friends. Welcome to the show In Search of Lost River Saraswati. Our guest in the show is Dr. Utpal Bhanja, an oncologist by profession and Indologist by passion. In the previous episodes, Dr. Bhanja told us the importance of river Saraswati in Vedic scriptures, Mahabharata and Puranas, and how these scriptorial descriptions relate to modern day findings, the opinions of various Western and Indian scholars. In the last episode, Dr. Bhanja also described to us how remote sensing data supports the existence of the lost river Saraswati. Let's go to Dr. Bhanja and understand what additional evidence are present to prove the existence of river Saraswati. Over to Dr. Bhanja.
Dr. Bhanja, in the previous episode you mentioned paleo channel. Today also you mentioned the term. For our viewers, would you mind explaining what paleo channel really means?
Kaushik, it's a very good question. Yeah, I think I should explain what paleo channel is before we proceed further. And as the name implies, paleo means old and channel means canal or drainage or river, anything. So paleo channel in geological terms implies the sediment that has filled into the riverbed of an old extinct non-functioning river. That is called paleo channel. And there is telltale sign in the geological sense of those channels on the earth's surface or subsurface region.
Thank you, Dr. Bhanja, for explaining paleo channels. So, what evidences are we going to discuss in today's episode?
Kaushik, let's discuss geological, that includes geophysical, geochemical and other geology related studies, hydrological, climatologic, seismic studies, environmental studies rather, which we actually can be lumped together, and archaeological studies I'll discuss in the next session.
Thank you, Dr. Bhanja. Before you get on to the detailed discussion, can you please explain the scientific principles behind these studies?
Okay, Kaushik, you asked a very difficult question because I am not the specialist in those fields as well. I am a physician by profession and this is my passion. But anyway, I try to understand, I will explain in a simple layman's term whatever I understood about the studies. Say for example, the geological studies may include electrical resistivity studies. What is that? All substances or matters has degree of resistance, electrical resistance or conductance to certain degree. And say for example, a wet sand would be a better conductor or a less resistivity than the dry sand. And say for example, mineral content of the earth's content, surface contents or sand, etc. can affect the electrical resistivity. So studying the electrical resistivity, the geologist can determine what is deposited at different depths and also the width of that deposit. That's what the electrical resistivity study is. Besides the electrical resistivity, there is another important study is involved in this research is isotope studies. Say, for example, we know that there is a heavy oxygen, not the ozone I'm talking about, heavier oxygen and heavier hydrogen, deuterium and tritium, which is H2 and H3. They are present in a small amount in the atmosphere, and they also form water molecules to some extent. So when there is a precipitation, there is water molecules made of deuterium or tritium also comes down to Earth's surface, and depending on their half-lives, their amount would be going down, and this can be traced that how old the water content is by studying these radioisotopes of the oxygen or the hydrogen. Also, I think we all know there are organic elements, say mollusks or shells, there is carbon content in it, and there is also some C14 already embedded in the living matter. So depending on the decay of the C14, we can do a C14 dating, carbon 14 dating. Also there is called optically stimulated luminescence dating. So these are the different physical and chemical principles that are used in the geological studies. Okay, I think that answers your question, Kaushik, and hopefully you get the basic idea about it, right? Thank you.
Thank you, Dr. Bhanja. Let's hear the actual studies now.
Kaushik, this is a very vast subject. There are so many research papers published by several researchers in India as well as in the West. From all over the world, the scientists are doing research and publishing papers on a daily basis. In the last 20-25 years, there have been a plethora of papers that have flooded. But let us pick up the important ones, 10 to 12 of them, and the details is very technical. I mean, it is very difficult to explain. Even I do not understand the technical part of it. But I can discuss the summary or abstract of the studies and what that implies and what it means to the status of river Saraswati and its timing. Of course, there would be variations in the inferences by different researchers. I will at the end tell you why the variation is there and how we can narrow down the variations to the particular area of interest. Okay, let's start. In 2009, Saini et al. Found the channel activity during the mid-Holocene in a part of the Haryana plains, and a second fluvial phase represented by a paleochannel segment whose signatures he found to be dated between 6,000 and 2,900 years ago, which they call kilo years ago. That means 4,000 in our term, between 4,000 and 900 BCE. Said paleochannel runs very close to the current Ghaggar. Its window of activity, which brackets the Indus civilization or Harappan civilization, or currently we started calling it Indus Saraswati civilization, suggests that the Ghaggar had partly revived or was somehow persisting in that period of time. Both the authors, Saini and Mujtaba, in 2010 confirmed these findings in a study of the same paleochannel published in the next year, which concluded that the channel received enough water supply between 5,900 and 4,300 or 5.9 and 4.3 kilo years ago. In fact, Saini and Mustafa's study mentions the river to be fully functioning or flowing with full force between 3,900 and 2,300 BCE, after which, for some reason, the water supply or headwaters was stopped for the river and slowly dried up. Another study by Kshetrimayam and Bajpayee in 2011 conducted a geoelectrical resistivity survey of the area between the river Markandeya, a major tributary of the Ghaggar River, and the current river Saraswati. There is a small river that is flowing in the northwest India, is called Saraswati. Their study revealed extensive water-bearing buried sand channels composed of coarse sand with gravel at a depth of 10 to 100 meter and fine sand beyond a depth of about 45 meter and extending laterally over some 12 kilometers, connecting the Markandeya river bed with the Saraswati river bed, which authors identify as the Vedic Saraswati in this study. So I mentioned about the coarse sand and a fine sand. Fine sand is an indicator of sand from a higher Himalayan region. Okay. Clift et al. In 2012 dated zircon sand grains from trenches and drilled cores at 4 sites in Cholistan. By comparing the zircon grains with those from other regions, the geologists concluded that the Yamuna was once flowing into the Ghaggar Hakra but switched eastwards tens of thousands years ago. The Sutlej also contributed to the Ghaggar system but abandoned the river about 10,000 years ago or earlier. As a result, any drainage capture affecting the Ghaggar system from these two river systems appeared to have occupied prior to human settlement, because presuming the human settlement started after 10,000 years ago in the beginning of the Holocene period, and these not to have any direct cause of the Harappan collapse. Geoshan et al. In 2012 led a more comprehensive study which rejected the possibility that the large glacier-fed Himalayan river watered the Harappan heartland on the interflow between Yamuna and Sutlej. Instead, they proposed that only monsoon-fed rivers were active during the Holocene. In particular, the rivers were undoubtedly active in this region during the urban Harappan phase. According to them, the study found sandy fluvial deposits approximately 5,400 years old at Fort Abbas in Pakistan in the Cholistan desert, and recent work on the upper Ghaggar Hakra interflow in India also documented Holocene channel sands. So, according to them, the Saraswati lost its glacier origin in the beginning of the Holocene period or during the urban Harappan phase, but the monsoon-fed Saraswati was flowing all the way and watering the Harappan heartland at that time, which is actually in contrast to Valdia and others' conclusion that Saraswati was a glacier-fed river in the Holocene period, in the first half of the Holocene period. In year 2013, Sinha et al. Did another geoelectric resistivity study and offered stratigraphic evidence that a paleochannel exists in the subsurface alluvium of the Ghaggar Valley. The couple of the major urban sites such as Kalibangan and Kunal lie adjacent to this newly discovered subsurface fluvial channel body, suggest that there may be a spatial relationship between the Ghaggar Hakra paleochannel and Harappan site distribution. The reliable dating of this buried water-bearing sand body was beyond the scope of the study, but its importance lay in firmly establishing the presence of subsurface water-saturated sand bodies, which were already detected earlier but much less precisely through surface surveys, open wells, satellite imagery, etc. This was also independently confirmed by a careful isotopic study of the sediments, which found them to represent a buried channel sand bodies deposited in the Ghaggar plains through a large river system and probably originating in the higher Himalayas. Another 2017 study by Darkan et al. Sampled 11 locations in the lower Ghaggar basin, mostly in the state of Rajasthan, and dated their sediments through OSL or optically stimulated illuminations. They found the fluvial deposition which predates 5,000 years. Although the fluvial deposits in the Ghaggar Paleochannel dated at 3.8 and 3 kiloyears ago, between 1800 and 1000 BCE, which is after the decline of the urban Harappan civilization. So it was postulated that there have been occasional revival of the Ghaggar, a low energy possible ephemeral flooding, and this was confirmed from the samples obtained from the Kalibangan and further downstream as well. Chatterjee in 2017 sampled subsurface sand bodies present beneath the modern Ghaggar alluvium along a long stretch, about 250 kilometer stretch down to Anupgarh, and encountered layers of subsurface grey micaceous sand body all along the Ghaggar plain. Actually, let me tell you one thing, that this grey micaceous sand has long been identified in geology as originating in the higher Himalayas, as it is not present in the Sivaliks. It thus points to a glacial source of Saraswati, which several studies in the past considered must have stopped by 6000 BCE at the latest. Chatterjee got the following OSL dating of the sand horizon, and rounding numbers, it would be 36,000 years ago between Hanumangarh and Kalibangan, 19,000 years ago north of Kalibangan. However, a sample at Hanumangarh returned much more recent dates of 3,400 years, 4,000 and 6,500 before Christ or BCE. And at Anupgarh, a colony of freshwater bivalve cells was encountered embedded in situ within this micaceous grey sand layer. And the cells contain carbon, and they are a good proxy for C14 dating. And also the cells by C14 dating yielded dates of 4000 BCE, corroborating the other finding of the sand dating. And this was thus considered as the depositional age of the fluvial sand horizon. The next study is a very interesting study done by Chatterjee and Roy in 2018. They not only analyzed the sediment samples from the Ghaggar Valley, but also, or Ghaggar Paleochannel, but also for the first time, they analyzed the material used in the manufacture of mature Harappan pottery from Kalibangan, and presumed that the local potters in Kalibangan used the clay from their local riverbed. That the potters in the Kalibangan or the area used clay from locally. Both proxies were dated through optically stimulated luminescence or OSL. The sediment samples chronological horizon showed that the Ghaggar had changed from glacier-fed strong fluvial system to a rain-fed or monsoon-fed alluvial river during the Holocene, because there was a clear absence of the grey micaceous sand component within the pottery, which implied that the time of the mature Harappan settlement in Kalibangan, by that time the glacial connection to the Ghaggar was significantly reduced, period. Sinha and Khan did another study in 2019 and conducted geophysical survey of the upper Ghaggar, studying its paleochannels that connect the Jamuna with the Ghaggar system with through resistivity soundings as well as well logs. These paleo-Jamuna channels had long been traced through the remote sensing satellite and are part of the current Choutang River system. In a fine confirmation, the study evidenced wide subsurface sand bodies at a depth of 10 to 20 meter and typically 30 to 50 meter thick. The study actually showed that the Ghaggar or Saraswati lost the connection from the Jamuna about 30 to 50,000 years ago. And the Sutlej was also connected with Saraswati, and the connection was lost about 8 to 10,000 years ago. Dave et al. In 2019 did another study which concluded that all the major rivers of the Himalayan origin ceased to flow through the northwestern region of India during the most part of the Holocene period. Let me quote another study, a very data-rich study done by Singh et al. In 2017, and they investigated one of the paleo channel of the Sutlej, which connected with the Ghaggar system or the Saraswati paleo channel system. Dating the sand grains through OSL or optically stimulated luminescence dating showed that the flow of the Sutlej in this course terminated considerably earlier than the Indus urban occupation, such as Harappa and Mohenjo-daro. So they boldly concluded that it was the departure of the river rather than its arrival that triggered the growth of the Indus urban civilization or Indus cities. And I think they've also referred to Rakhigarhi, which is at the bank of paleo channel of Ghaggar Hakra, and has been dated to be at least 2000 years earlier than the Harappa Mohenjo-daro along the bank of the Indus. I think that concludes more or less the important studies, all the geological and geophysical, geochemical data. We'll have to talk about the archaeological findings and also the reason for the demise of the Saraswati River and vis-a-vis Saraswati civilizations based on climatologic and seismic or environmental evidences. Thank you for listening. I will see you again in the next episode.